The seemingly simple polar coordinate equations can become quite complex when transformed into rectangular coordinate form, and vice versa. What is required for such transformations are the following four coordinate transformation equations. Let's consider the following equation. Multiply both sides of the equation by r. The left side becomes r squared, and the right side becomes 6r cosine theta. Using x equals r cosine theta from the previously seen relation. Replace r squared with x squared plus y squared. Apply completing the square to the equation. Add and subtract the constant 9 inside the parentheses. Take the constant -9 outside the parentheses. The terms involving x are transformed into a complete square. This is the equation of a circle with center 3 and 0, and radius 3. Confirm by graphing. Here is the equation. Multiply both sides of the equation by r. The left side becomes r squared. Substitute x squared plus y squared for r squared, and y for r sine theta. Apply completing the square to the equation. Add and subtract the constant 4 inside the parentheses. Take the constant -4 outside the parentheses. The terms involving y are transformed into a complete square, and the constant is moved to the right side. This is the equation of a circle with center 0, 2, and radius 2. Confirm by graphing. Here is the equation. The cosecant function is the reciprocal of the sine function. Multiplying both sides by sine theta, we get r sine theta equals 4. Substituting r sine theta with y, we get y equals 4. This is a horizontal line. Here is the equation. Multiply both sides by r. Substitute r squared with x squared plus y squared, r sine theta with y, and r cosine theta with x. Rearrange the equation. Apply completing the square. Move unnecessary constant terms outside parentheses. Move constant terms to the right side. This results in the equation of a circle with center 3, 2, and radius square root of 13. Confirm by graphing. Now, let's try to convert equations in rectangular coordinates to equations in polar coordinates. Expand all the equations. And simplify the constant terms. Replace x squared plus y squared with r squared, x with r cosine theta, y with r sine theta. Factor out r as it is the GCF. Two equations are derived. r equals 0 represents the origin, which is not our concern. Eventually, the equation is obtained. What about x equals 3? As seen in the graph, it is a vertical line. Substitute r cosine theta for x. Divide both sides by cosine theta. This yields r equals 3 secant theta. And what about y equals 2? As observed in the graph, it is a horizontal line. Substitute r sine theta for y. Divide both sides by sine theta. This gives r equals 2 cosecant theta. What if theta is given as pi over 3? In the coordinate transformation equations, there is tangent theta equals y over x. Substituting pi over 3 for theta. we get square root of 3 equals y over x. Thus, the equation of the line y equals square root of 3x is obtained. Confirm by graphing. See you next time.